maintenance rather than sticking with a planned routine maintenance. The costs are amazingly high. And of course, there is in automation and manufacturing, all these sensors and tags provide a lot of opportunity to improve quality or reduce defects. Just to give you an idea of the monies involved, if you will, farming equipment, airplanes, railroads, all these transportation equipment, the windmills. So the common theme here is they are very high valued assets. Maintenance is expensive. If you look at the planned maintenance spend are in billions. And downtime is not acceptable or very expensive. So highly reliable systems with high availability requirements. So this is where we entered a few years back, 4 or 5 years back, into the predictive maintenance area and exposed to these sensors. Data dimensions, again, I started my career, like I said, 28 years ago, getting weekly clean inventory numbers at the ERP evolution was a huge deal. So one number now we are getting like 60 reads per second on hundreds of sensors. So this is just on the example of an airplane, and the airplane will come in 2020. Each plane will have 7.5 terabytes per day, and just in US or over US, there are 5,000 aircraft in the sky. So what we are looking at, and the business case is SaaS, what we need to do is look, let's say we are looking at windmills. We need to look across windmill farms to understand more or model. What we call it is multi-phase modeling. We need to model the behavior of stable operations or failures at data at rest. We need to apply some of these into the data as it streams in. And SAS has an event stream processing engine. So we are embedding analytics that will create value-add transformations. Do I really need 60 times a second that this temperature in this room is 72 degrees? Or should I look at only carry to the server side or the cloud when it exceeds a certain number? Because the rest is not useful information for predicting anything into the future. We're also looking at different aggregations, whether keeping track of range. For example, when we are talking about electricity and voltage and these reads, the variation in voltage is more of an indicator of failure than, or problems than actually the number itself. So we're putting these transformations into the streaming engine. So the data that goes to the cloud, it gives us predictive power, but we reduce both the noise and cut down the expense of carrying all this data. Last night at dinner we were talking, manufacturers and all are collecting quite a bit of data every day, but it's sitting in manufacturing floor because they know there's potential in this data. They don't know which part of it to take to the cloud. The other algorithms that we've been working on is newer outlier detection algorithms. So we want to catch an anomaly. Most of the use cases are so. Dimension reduction, when we're talking about 200, 500 sensors and trying to predict failure, you know, there is whether any one of them had really any impact. So dimension reduction techniques are coming in handy. Again, the major goal is catching early degradation of the system. And many of these systems, since they're so reliable, they do not have too many failures in the past. So it's, when there is not any failure, it's hard to get a statistical signature of a failure. So what we do is we model, and I'll give you an example of what does stable operations look like, projected into the future, and then look at the incoming data as the things stream in, whether it's staying within the confidence intervals of the stable outbreak. So our goal on the streaming side is filter, aggregate, create meaningful alerts. And we are doing, because there is a lot of sound and vibration data, we are seeing better results where there is in the frequency domain rather than time domain. A couple of examples of that. So I don't know if I explained well as to the multi-phase analytics, because I can learn from multiple equipment over time what normal looks like or what failure looks like, and be able to apply it to the individual machines in real time. I don't know, something happened, you got internet service.
Well, can I ask a question?
Sure.
Do you have like signature-based detection of like a failure? Like a
It has happened. We call it motif. Motif is a sequence of events that we can capture, motif discovery, and then trying to, like we do that on EKG data to detect arrhythmia. So we know what each individual, so normal per each individual could be different. Your blood pressure could be different, but we can capture the normal EKG signal and interpret it depending on the activity that we detect you're doing. You know, your EKG or your heartbeat will look different when you're running versus when you're sitting. But if there is arrhythmia, we look at the motif density, anything that falls outside the normal pattern, because you need to time warp it if there is a ramp. So we're investing in motif discovery and motif density to detect such failures. Did I answer your question?
No, I'm just thinking like in IT we look for viruses.
Yes.
When you're detecting viruses, there is an anomaly that you're usually looking for.
Yes, definitely.
So I was thinking about the same thing with this type of sensor data.
Yes.
If you get a specific type of anomaly, it might be telling you of a specific type of failure.
Yes. So we're, when I said outlier detection, we are actually looking for an anomaly. We're investing, and I'll give you an example of detecting when something doesn't look normal. And that's, I think, probably along what you're doing in cyber virus security. Yes. 5 minutes. Oh my God. If I can't move. Oh, there we go. So this is a new, sorry, I went too fast, I think. Yeah, new machine learning algorithm. Again, not each tractor or windmill will behave the same. They are a human body, but they will, what we are finding is that they will change their behavior in similar fashions under different conditions. So similar, like windmills, they could be at the bottom of the hill, at the top of the hill, but they will behave together. And this is actual data. If a machine is degrading, then it is going to separate from the flock. A really easy idea. Variation to the theme of principal components is called moving windows. So we can look at little windows and see these are multiple windmills. The vertical lines are failures in those windmills. And you can see, like the green one is always off the flock. You know it's going to fail. And the yellow one gives signs of separating from the flock early on. We are looking at first principal component here on kilowatt hours of production. And it gives a really advanced notice of turbine failure on windmills. Since windmills need to have special equipment to be maintained, any advanced notice is better than it's broken and then you wait for the maintenance equipment, etc. Another one, this is also a variation to the theme of PCA, robust PCA. It basically separates low-rank matrix from a sparse matrix. This is the actual video, and we are able to separate the background from the foreground. numerical, it applies to numerical data too. It dynamically calculates both. If you stand in one spot too much, you become part of the background. But if we know the background, so with the data at rest, we can always feed that to the streaming. If we know this signature, this is what background looks like, we can feed it, and we can also detect only the anomalies or the changes in the foreground. And this is what I was mentioning. This is in natural gas. We pretty much can detect, we can model what stable looks like, project it ahead, and if it's off our confidence intervals as the new data comes in, all the red dots that are coming in, it's a warning that something is about to fail, something needs to be taken care of. And if you looked at only the natural gas flow and the chemical they put into it, you can see there was a failure here. They think they made a correction. This is when it went down totally. This is a multi-million-dollar cost at this point when a natural gas filter goes down. Well, all along, the stability monitoring was telling them you're off my confidence interval. Confidence limits. And again, I'll go very fast through this. Sound data, vibration data, especially in mechanical failures. And I'll give you an asthma detection example here. Coming in huge, we are expanding our capabilities here. And we are doing, I think everybody must have taken a class somewhere in undergraduate on Fourier transforms, taking a timestamp data into frequency domain. We're doing this in very small windows and looking at spectrograms. I think it's going to come in very handy. This is, I think, a nuclear reactor site where there was a failure in a power utility. The failure is in this bed. Failure happened right here. And this is, so we were seeing some red in the frequency domain spectrogram. And we looked the day before, the week later. The thing is, it detects something is looking weird or anomaly. We don't know why, but it gives a good alert for the domain experts to look into the generator. I think I went down. This is a cool example, I think, applying the, I don't know where it is. There you go. That's not a slideshow. So the breathing is detected through a microphone on a health wearable on the chest. Asthma kills 500,000 people. It's once you can detect it early on, it's very curable. And the goal is to lower deaths and emergency room visits. And I'll let you listen to it if I can. I might not have audio here. This is a normal breathing sound if we have sound, and this is how the frequency domain spectrogram looks, pretty evenly separated. And this is wheezing. And if you listen to if we could listen to the sound, it sounds like a whale, you know. And this is continuous wheezing. It gives a very good signature of what wheezing looks like. But I can't play the sounds for you. And this is the onset of wheezing. Although it's not continuous, we get a very good signature of, this is a 3-year-old's 4 breaths with the frequency short time Fourier transforms. And that's where the streaming engine needs to pick up this signal. It's really cool if you want to watch it, but if you can play, I don't know. So this is the same data streaming in, giving us these indications on the frequency domain, but this is not the setting we're using. This is when it is time to give this child an inhaler so he doesn't end up in an emergency room. And so although we have captured the signature in the frequency domain of a normal breath and wheezing with data at rest, we are actually scoring it and creating alerts through the event stream processing as the data is coming in real time. So it's a good alerting mechanism.
How big are your sample windows?
You can set it up. In this one, it's, I think, 5 seconds maybe, less. So the little squares that you're seeing are all windows. It is adjustable to the domain.
We're talking seconds, not nanoseconds, or microseconds.
Seconds. Yes. I mean, you can do it less than seconds. Depends on what the data was coming in. The event stream processing engine works with any sub-second data, so we can run this with sub-second. Thank you very much.
Well, as we're working on this device, actually, I briefly introduce myself. I'm Rongduan from AT&T Research Lab, and this is my 20 years AT&T Labs. And for my whole career, actually, I deal with the data with different stages. And in AT&T, for the big data research, actually, we have 3 groups. And one is the statistics department, and I'm in the statistics department, and one is database, and the another one is the new one, actually, is the machine learning groups. And AT&T as the service provider, we have a lot of this new concept. It's build this smart house, smart home, actually. And IoT, when Kaibo asked me to do this panel for this IoT stuff, I think actually this is a really big topic. So the IoT will involve a lot of this policy issue, privacy issue, homeland security. So that means IoT, what means IoT? That means you have a lot of sensors or a lot of devices monitor human behaviors or this machine behaviors. So a lot of this stuff involve the management issue. Since I'm in this big data research, what my concern is how do we manage the data? It's not the policy issues, not my focus today. So I will focus today is this quality issue. And the girl and Sarat, right? Yeah, they all mentioned about this missing value, outlier detection, all this stuff. And for me, actually, for us in lab, we are more concerned about this quality. When you want to do this good prediction or modeling and the fundamental lines, you have the good quality of the data. And for the streaming data, it has its own challenge. It's different from all the other different types of data. It's kind of streaming, it's very fast, and you have this lightweight algorithm to detect the quality of the data. So that is my focus today. Oops, this doesn't work. This doesn't work. Switch to the internet. Okay. Yeah, I don't know the other industry. I believe for most of this data-rich industry, when they build, no. Oh, yeah, okay, it works. And then stuff. Oh, maybe you. So for the data-rich industry, their data actually they store. It's in this. Okay. I hope this slide will not make you feel dizzy. Actually, it's basically for this industry right now. At least for AT&T, we do organize our data in lake. It's kind of cloud somewhere, and especially for the stream data. When you collect the stream data, it's not, when we talk about the real time, it's not when you use it right now and then next second we're going to deliver to this, we give you this analytical result right away. There are a lot of different procedures to deal with this. And actually, we have this different steps. We have collection, and when you collect different data sets, and actually each data set you need to integrate with other types of data. For the stream data itself, the stream data, and most of the time we need to integrate with the reference data. For example, for this consumer data, you might integrate with this consumer. There's some properties with the consumer or demographic, this kind of information to get more business related this output. So I put this reference data, and you might have not only one sources for that. So you have different types of reference data, and then you have stream data. So for this, if you look at this vertical, this is the data collecting procedure. And after you do this, collect all these data sources, and then do the integration, and then do deliver, and then you have the data product. And this is just, you look at this vertical. And if you look at the horizontal, it's by nature of the stream data. It is coming by this time step over it. Actually, there are more complicated issues. I didn't show you right here. At each stage, actually, they might have their own time step. They might not line up with all this time step and the final product. I'm gonna discuss about that later on. So this is kind of this procedure when we collect the stream data, and we have a different stage to collect it, and for stream data, and we need to monitor each steps and what's the quality of each step. So that is we see about this data product. And in AT&T, we do have this feed management system, so to monitor the quality of each step. And we monitor at the vertical and this horizontal at the same time. And for the data feed management system, actually, it's kind of a centralized database. And we do have a lot of publishers. So we have different data sources. A lot of people can publish their data over there. And then have a lot of subscribers. They're going to subscribe the data from the centralized database. And there are also these quality issues right here. Since there's network failure, all this, these traffic issues, and the publisher and the subscriber, they might get different data set. And even this same subscriber, different subscriber, they might have this different data set because of their local issues, the machine failure, this kind of stuff. So we do have this monitor of this the logs to monitor for each data set. Since the stream data is really large, and then for each step, we need to monitor the quality of this incoming and outgoing this data set over there. So that is our data management system. And for the stream data and the quality actually has its own properties, some uniqueness of the stream data. Missing value is very typical for any data quality issues, right? The missing value and outlier and out of order issue. For stream data, there are out of order issues. So your record should be delivered at this time, but maybe it's delayed by some reason. And then they're gonna mess up your stream properties. So when you detect this failure of the stuff and they arrive late, so they're gonna mess up your patterns. So there's out of order issues you have to pay special attention. And also the duplicates. The duplicates is also happens when you recover your data, the stream data. There's a failure, you recover it, and you might duplicate some records. So you need to detect this duplication over there. And there's a level shift, and also the incomplete. The incomplete is kind of in the stream fashion. And most of the time, you need to give some prediction, and both scale and sorry. Yes, right. They all mention about this prediction of the stuff, and sometimes when you do the real time, your data might not fully, completely come in, and you need to give some decision right away. And how do you give this confidence bound? You give this prediction. How confident you give this prediction? And how do you estimate those stuff? So this is incomplete, and how accurate your result. So that is one challenge we need to deal with. So incomplete. I showed this data right here. Actually, it is the stream data and the two data sources right here. And these are highly correlated data source. But right here, there is a jump between this red box right here, and then this one is kind of a little bit higher than the previous, even there's a higher value right here. So people thought maybe reasoning about it, there might be the out of order issues. And also right here, there's some missing here. So, and also this, if you look at this relation between the red and the blue, and you see, wow, the gap is a little bit larger than the others. So this is also this, when you look at this stream data, it's not only this, you look at this data individually, you have to look at this multivariate types of points. So they might have these relations over there, so you have to look at that way. So that is the quality issues in the streams. And then actually, I just gave you this very brief introduction of what's the quality there. And now I want to talk about this, the open problems. There are some research points, the questions right here. So when we talk about this quality measurements, people always think about, okay, the quality is outlier detection, all this stuff. But from the data management point of view, and this outlier, the missing value is different from the regular, abnormal detection, anomaly detection point of view. And the question is, how do we generate quality measurements when we want to measure the quality? So for data, some data, the stream data is by nature, it has some matrix, you can measure it. But some data set is really hard, and only by this natural measurement is really hard to detect. And how do you generate this quality measurement? You might need to do some aggregation, as Bill mentioned, and they do aggregation for the monitor this stream data, and the kind of you have to have some signature. And especially for the stream data, you want to have something simple. You can measure it very quickly. So that is how do you measure this quality? Right now, most of the time is you predefine the measurements. So I define, okay, how many files I should get in at this time frame. So then you predefine is, okay, I measure the count of the files. But how do you automatically from the data set, could I generate some quality measurement quality to monitor my quality? So that is the question. Actually, that's the question bothered me for a long time. So if you have any answer, just let me know, right? And then other things is how do we learn this ideal data? When we talk about the missing value or this missing value is easy, just missing, right? But sometimes the missing value is a kind of it's hidden missing value. So they have some values there, but it's not a reasonable one. For example, for the records, they might have some. I want to give examples categorically. So you have usually when we do this missing values, okay, there's this cell, this column, there's no value there. We consider as missing value. But sometimes they have information. But this information has no use. This is also the missing value, right? So this is kind of, when we talk about this, when we learn this abnormal stuff, that's missing, we contrast with, we know this ideal status mixed together. If you have this domain knowledge, or you know, okay, we should do the data should performance like this, but if you don't have the domain knowledge, how do you learn this ideal data? Right now, from the statistics point of view, we do have modeling. So we remove this outlier, remove all this level shift, and use robust statistics, use this median or this method, not use this mean, this stuff. But it's still limited. Is how do we deal with, I learned that's the ideal data, it's chicken egg problem. Yeah, there still is a challenge issue over there. And then another thing is how do we capture the evolving of the stream data? Yeah, when we talk about stream data, it's keep changing. It's not to say, okay, I have the pattern today, tomorrow is the same. Well, today, tomorrow is maybe too short. Maybe next month, it's not the same. For example, for telecom, there's data usage. The data usage, this month, next month, maybe big difference. So how do we do this incorporate the involvement, okay, in this when you do this quality control. I'm still focused on the quality control. So you need to build this robust model and capture this involving of the stream data. And there are some approach right now. We have the human in loop. We have some feedback from this user use it. It's okay, it's time to change the model, or they have some interact between each other. And another one is what we focus on is data-driven one, and we try to build a model actually is really robust and to capture this involving in this data stream over there. And the crowdsourcing is in these few years is kind of a popular methods how to utilize the crowdsourcing and to give you some suggestions to tell you there's something going on and you can integrate that part with your modeling this stuff. And another thing is a distributed system. For all this IoT system, they are complex system. They are not only have one server and they keep sitting there collect data. They have multiple servers and maybe this distributed system. And how do you monitor this quality of this distributed system? And how do you do this data fusion? When you collect data from different servers, and how do you put them together? Right, because that is the data fusion. I think it's it's pretty hot topic in these few years too. From different devices, different technologies, and how do you integrate this data together? So it is still the challenge right now. And another thing I say, I want to see how do we evaluate data quality matters. So data quality is most of the time we don't have the ground truth. So when we see this outlier, and most of the time we have to dive into it to see what's this driven factor of this outlier. And when you only look at this data, you only see, okay, there's a bump over there, but you don't know what's the reason behind it. So you need to dive in to see what's going on. And we need to have this, because that is kind of human beings involved. So we need our human beings, this knowledge to involve. But how do we have this quality measurement to see this is good data, this is bad data? So that is very important. And another one, actually, the project I'm working on right now is how do we combine this different alarms from multiple methods. This is kind of like this ensemble method, but it's not the same as ensemble. Ensemble is you have the classification and the label. But for the quality things, you have a bunch of different algorithms. So you have all this Z or Hanko, DK, or this clustering, all these different types of this algorithm, and it tells you the different data points and outliers, and how do you combine them together. So that is the challenge problem. Yeah, I'm working on. If you have any suggestions, please let me know. Right, this is because of this data quality, you don't have the label data, and you don't have something to minimize or maximize, optimize, right? So how do you combine this and say, okay, this is a combine of this the best combination of all different algorithms, give the different weight, right? So that is the combine alerts from this multiple matters or voting this stuff. So that is my some 2 cents of this data stream. Okay.
So, any questions? First one usually. Right? So probably I can ask the first one. So we talked about for this email since this enable. So in your view, what is the differences, or which one of the bigger concepts, or I just want to hear your opinion. Simply analysis and IoT.
Go ahead.
Yeah. I think big data analytics applies to many different domains where the data is a bit more structured, you know more about the data, and it's data at rest. So I think that field is a lot more mature than the IoT, where it's new data. Mostly nobody has looked at it till some analytics reduces the noise that's in the data. And plus, some of the execution of analytics needs to be real time. And so I think it's an additional challenge. And again, I would go with more unstructured, more unknown, hard to put any statistical assumptions around the data, so we need to look at more non-parametric models to model them. That's my thinking.
Yeah, actually, from my point of view, I think there are two overlapped this topic. For big data, actually more focused on data, and for the IoT, we might involve this hardware stuff. So for the people do this big data, they might find this point of view, from this machine learning point of view. Most of them don't have hardware involved. And if you do this IoT, you might need some this hardware as a domain expert to help you to understand what's the data. And that is one thing. And another thing is for the IoT, purely from data point, it's just a special application for this big data, so streaming. And the stream, it has its properties. And you have to do something very fast, especially you want to do this real time. And the algorithm cannot make this fancy, complicated this algorithm. You might need to have this lightweight algorithm. So the computing, and this is most of the time they talk about the memory. Memory is limited. You can only save this much of the data. And how could you capture this data, this signature, and save it, and then to compare with the future data. So that is this stream, this fashion is kind of unique for this IoT data. Yeah. And I'm sorry, I'm not sorry. And also this IoT, I think is involve a lot of it's similar with from the policy point of view, maybe similar with big data, this privacy issue, and this maybe this if you involve this government, the homeland security issue, and that is the common stuff for both big data and this IoT need to solve to answer. Actually, we don't have a standard right now. How do we deal with this stuff? Right. So this is the common.
That's a good way to think about it. IoT has a big data aspect plus other challenges.
All right.
So IoT, from my perspective, IoT and big data, they share many similarities, particularly volume. And big data is more into variety, and IoT, what I have seen, you can take it as structured data. It is voluminous, like lots of data, but it can be structured. But big data more into unstructured, like we have log and log. So these are a lot of similarities.
How can we evaluate the value of data in the balance sheet of enterprise?
The balance sheet for IoT data? Yeah, I think to his point, I think incremental benefits from gathering and analyzing this data will eventually make it to in the maintenance area, reduced maintenance costs, increased availability, better quality. Those are the things that will make it to the balance sheet. But I think getting the initial wins from the data, it seems to be the current challenge in most of the customers we meet. They know they'll impact the balance sheet. The how and when is the one. So low-hanging fruit is what everybody goes after initially. You go after the most expensive machine, catching the most expensive maintenance issue. And I think as it matures over, I think we're going to have fun with this at least 5 to 10 years when it becomes incrementally more and more value add to healthcare systems, to the industry, to maintenance. But,
I can add some stuff. In Caterpillar, we are now big time copying Google. Like in culture, like we want to instill that excitement, enthusiasm in our analytics division. They have created one division, innovation and analytics. So we are asking to our executives, give us all the data, like, just like Google does, give us all the data. So we will do so many things. And Google doesn't ask you to pay for the email service, but it somehow is. And if you book your hotel in Nashville, it offers services, it offers some users. Give us all the data. Again, it comes to incremental ROI. They push back. We will go bankrupt if we keep investing like this. Like one machine will, 1 month, we have to spend $750, and we have almost 500,000 machines in those areas. We can justify. So some groups, we are looking for some value stories. What I can do, that will add to the bottom line. What I can do. Just like one example, in mining industry, those machines cost like 5 million apiece, and all they are supposed to run 24/7. And the cost of downtime can be at the minimum $5,000 per hour. Depending on the material, it can be $30,000 per hour. So we are targeting those. If I make this much saving with this IoT-enabled like machine data, and I can harness the insight and stop bleeding, it will save some. Okay, and then we try to come up with some value story that will give us some incremental ROI. And we know, just like that video said, I showed you, we are on the flat. We have to build our own plane, and we cannot wait for the whole thing to mature, then I'll make a decision to invest and all. So we have to show the incremental ROI and just navigate through this emerging technology.
Well, from my point of view, it's back to data quality. Yeah, actually, we do have a lot of data, and I believe every company buys data from other outside these companies too. And they usually spend a lot of time on this buying this other type of data. And actually, we figured out a lot of the data we bought actually a lot of garbage in it. So it turns out it's kind of a big waste for this company to buy this large of data. So it's kind of a question for our industry. They want to buy a set of the data. They need to do this quality investment first. So it's we do buy data from basically all this the data they collect is in U.S. for the business. The business, their number of employees, locations, and this data. And actually, we help them to clean their data. So they spend a lot of money on that. But it turns out it's kind of, we have to put extra resource on that to clean this data. So we consider to have this big data, no matter if you collect it or you buy it, and you have to put the quality in front of every data you get. Right, then talk about this, the money you can make based on that.
So, I mean, this is kind of just a very general question, and you've talked about smart houses and Caterpillar makes, you're an OEM, so how do you think that, Internet of Things enabled analytics is going to change the way we design these systems and the systems that go around the systems that you're thinking about?
Actually, sorry.
Go ahead.
So when you do this analysis, usually you could do the smart house, this stuff. You do this customer behavior, this profile, this analysis. And if you learn more, just like Google, they learn your behavior more. They know what you want next, right? So this kind of depends on the data. We do the analysis. We can predict what's your preference, and maybe that's what you like, and we can do this. Okay, just recommend you some other services. We have this sensor installed on your refrigerator. Maybe you can recommend you install another one on your microwave. This kind of stuff. So that is purely based on do this analysis. And also you look for these similar customers like you and what they like. That's like the recommendation system, purely based on this analysis of your behavior.
If I understood the question, like in Caterpillar, we challenge each and every employee in the enterprise to come up with some use cases. Like we have already invested a lot in the IoT infrastructure, and knowing that it will evolve, it will change, but we have already made a lot of investment. And we run a challenge globally, enterprise-wide, it will come up with use cases, how it will hit the bottom line, if we can make an impact in a small way. So, like we generated around 300 ideas, that's all good. And right now we are pursuing 12 of those ideas. At least it will have impact on the bottom line revenue. So in that way we want to make it sustainable. So basically it is taking the design thinking, so how we will do it so that it will be embedded into the system.
I think here we talked a lot about data and analytics, but if you're meaning by infrastructure, I think we are seeing more and more in the hardware investment, the gateways, the edge. The cell providers, cell service providers, can I make a decision where to keep your service level, for example, both keep the customer happy and you and minimize the cost to the service provider. What I've been seeing is some use cases like the smart home is cool, but where the money gets invested is where additional value is generated. Whether it's industrial machinery or health maintenance by reducing costs. These are going after value generation in billions of dollars. I think if you need infrastructure like that, we'll see a lot more capable gateways, that will take updates to the analytical methods running there. And of course, I think the data governors, whose data is it anyway? We're seeing many companies who used to be manufacturers are now data companies. So I think there is going to be a shift at both the technology space as the value propositions change all the time. I mean, AT&T or any other cell service provider, they actually have so much data about each one of us. They could provide additional services to businesses beyond themselves as to, right now their marketing is selling their service. But do they have enough data or the rights to offer services from another industry? So I think as value gets generated, probably we'll see business models emerge that don't exist like that. We answered your question.
This is just a very general question.
Any more questions?
I think one big problem in IoT data analytics is that the data from different sources, so they are heterogeneous in nature. So I think this will bring problems in data fusing. So do you have any experience or thoughts on that?
So I don't think one should assume homogeneous data. Many things it's okay to have heterogeneous data or heterogeneous features that create an alert, for example. I think you mentioned how you need to converge IoT data with other data sources as well. Whether you do this as data at rest or as it's streaming depends on your use case.
Actually, right now in our lab, actually, we build this kind of data source by data source. It's more application driven. So this data set is different from the other one, and we do have this way to do it. And most of the time, we do need to do this some levels of this aggregation. This is one way to do it. And I know a lot of research papers regarding about how we do this fusion. This is kind of different data fusion. And this is the one thing actually is my own research direction. How to integrate this data and to guarantee this quality. So when you do the aggregation, you have some, you lost some information. And how do you keep this information and also do this integration at the same time? So that is, this actually is a very challenge problem now, right?
Yeah, just one point, it is an open question everywhere. Like if you see, there are many data providers like ENB, they just sell data. And when you ask for data globally, it varies so much. Like we get so quality data in the US, but if you ask for Saudi Arabia or some countries where you don't get that much data. And right now there is a push to connect this IoT data with those transactional data or their customer data so that we can get some more value. We are really struggling to do it on the global. That's why, just like Tom said, we want to do it just for US. Like separately, based on the data homogeneity, we are just doing it piecemeal basis rather than trying to do it globally. So much variance.
Comment was made that the anomaly detection can then provide some data to domain experts to aid in diagnosis. But do you see a role for analytics in getting deeper into helping with diagnosis, not just detecting anomalies?
Yes, over time. I think what we are seeing, like medical field, is a good one. The domain knowledge is growing by this new data. So as things mature a little bit more, because the only time the doctor has really monitored a healthy person is once a year, or a sick person in a hospital. But if they get this continuous information from many of us, from wellness wearables, then their own domain knowledge will grow. At the end of the day, we are going to get through that analytical life cycle, go from the explore and explain and predict to optimize. What's the software will. But I think many industries or many domains are not in that level of analytical maturity just yet. They're still dealing with, I have data, I have no idea what to do with.
Yeah, I want to add one more to that. So I know Eric before, and the question, it is very relevant to what we are doing in Caterpillar. In Caterpillar, as I said, we are getting data from lot of sensors and lot of different data sources, like 180 sensors, and there are other data sources like oil sample, inspection, and many things. And just getting the anomaly, yeah, something is wrong. And if you alert the customer something is wrong, they are just freaking out. Like if your car engine light just comes up every other day, you don't know what to do with it. Like you will freak out. So we have human in the loop. That is one way to mitigate that one. And when Eric was there, like he was doing a project with Spectrogram. And after that, we took it like another project. From that one, we used Bayesian. I'm not saying this is the only way, but one thing, we have multiple failure modes, and that can associate with multiple anomalies. And we just try to find the posterior with them. We have good information, okay, when this kind of failure happens, these are the anomalies we have seen. How about the other posterior? Once you get this anomaly, what is the probability that this failure might happen? So it is kind of giving some probability. So it is helping, but lots of failure modes and all, that is still a challenge, but it can, with lots of data, at least it can pinpoint to at least 4 or 5 things based on the posterior probability and it is working. So I'm not saying this is the only way, but that is one I have tried, and there can be many other ways. Then Bayesian network, it helped. On top of that anomaly detection, it is promising. I'm not saying 100%.
Yeah, actually, for the analyst with the domain knowledge, that's the type of data scientist, right? We want this to do this analysis, and they also has this some domain knowledge to see this is correct or wrong. And actually, from our side, we do work on some project for a long time. We do accumulate some knowledge of it. Especially we work with the customer care data and know what's going on there. But we still need to involve with the marketing people or involve with engineering people. If we have something, we always send an alert to them. But the good thing is we are this in-house. It's not this customer. It's not outside customer. We just send our in-house people, okay, there's something wrong with your data, and right here maybe missing all this part, and then they don't check, and then tell us what's going on. And then we just adapt our algorithm to see, okay, for the future, if this types of alert comes in, we just ignore it. So this kind of still is a human view. We have that. We have to have some experts to confirm there's something wrong and it's reasonable. Is that
Just want to add one thing. That human in the loop, like we have one 16 production that creates those anomalies, and there are some human people, they diagnose those and make some recommendations. And we started with a pilot in Australia, and suppose it, I'm not giving the numbers, but suppose it has only 100 machines, and they could get those alerts and translate it to some with their domain expertise, translate that to some recommendation to take some real action. But it was not scalable at all. Like when we opened it for other areas, we had 3 consultants. Immediately just it grew to 13, and after some time we stopped. Like, there has to be other way. We just can't afford to have human using their domain expertise to read those anomalies or convert it to some recommendations. So we need some automated way if we want to scale it up. So it is not scalable. Economically not feasible at all.
Maybe I can ask one more. So for the IoT-enabled analytics, I think not only there are videos perspective from the researchers. I heard one voice saying this is just a scale up of the algorithms that we have. We have a lot of machine learning algorithms, right? Data mining already it was like classification classroom, but now you have more data. There's nothing new. Just make sure you scale up, you upgrade your hardware, then it's done. Another way of saying, no, this is really a new challenge. We need a new thinking, new idea instead of follow the original path. So I just want to hear what's your opinion from your experience in terms of the use cases. You think which voice you will support more, or you have a different opinion?
I think both exist. Definitely IoT and the big data gets under rest. That does require cloud computing, distributed computing. We are having a lot of OR people in SAS spending a lot of time in internal optimizations of machine learning techniques. But it also is requiring us to come up with new algorithms, because the focus on, you're not going to build a time series model or a data mining model with 10 seconds of data. You're going to build it at rest. So we are focusing and adding functionality that you can fit or train at data at rest, but you can, the compute on the scoring side, on the real-time data is very late. Again, back to not making statistical assumptions of the incoming data. So I think there's a bit of both. Yes, everything that applied to big data needs to get even faster, and you see from all vendors that there are more distributed architectures and in-memory computations. But there's also a need to add new algorithms that are more focused on this two-stage analytics, if you will, multi-stage analytics. I thought.
So I see IoT as a customer experience the industry wants to offer, create some offering based on the possibilities. And machine learning is definitely an enabler, but everything starts with the customer experience. What we can do that will enhance that customer experience, and if it is possible, if they are connected. With those two, just connected assets, or connected assets means it can be anything, like your nest and all. There is a need that I want to come to my home temperature when I am leaving office. So that drives that, and internet connectivity enables it, and then machine learning algorithms and all, they just enable it to do it automatically.
From my perspective, I think for this IoT is just a special application for this use all different machine learning or statistical modeling. I will not look at the machine learning and stand alone this kind of the set of the technology. All the modeling stuff is not necessarily just feedback application of this kind of stuff. So for every application have their properties. This IoT has its own properties. So it's maybe this streaming fashion, or this also involves traditional hardware, the setting, or this stuff. So to me, I think it's just this one type of this approach. You can use any general algorithms or specific algorithm to solve it.
Maybe we have time for one more question. Maybe I'll ask a final quick one, and then I'll this session today. So we talk about IoT, and I think most of the company value IoT, thinking it's the future. But according to the interaction, my experience interaction with company, I think most of the company still dealing with collecting the data, make sure it's uploaded to the cloud, and so it have interface, everybody can access to analyze the data. But do you see any like mature industrial use cases that are already really implemented IoT-enabled maybe predictive analytics, quite mature, and also see the value, save several dollars. Do you have such use cases to share with us?
You mean use this IoT data,
Use
this
your
analysis
IoT
to help this?
To gain some benefits.
We don't have any production right now to do this. We do collect this data in the cloud, and we do analysis. But since this involves a lot of privacy issue, you cannot do this analysis at each individual customer. So not like Google, you can use it for free, you can actually give up all the privacy. As AT&T's legacy company, we have a lot of regulation, so you can only do at the zip code aggregate sum level. So it's not like this individual, as I mentioned to you earlier, can get your pattern. And this is wishful thinking, right? We cannot do at this individual level this analysis. So more is the aggregate level. So in research group, we have some algorithm to do it, but not in production. So whatever we do is marketing related. There's a lot of registration marketing issues over there. So in-house, we just develop some algorithm as to write a paper, it's fine. But if the public publish or not, it's need to go through the internal lawyer and stuff. So if you involve any customer related data.
So just for AT&T or for all this mobile provider?
I think for all this legacy telecom, we have this FCC regulation. So not like the new Google, this type of company. And there's no standard for them yet, so they can do whatever they want. It's not fair, that's the truth, that's the fact, right? So this is kind of, we do have a lot, if we want to mine the customer level information, it's a lot of restriction. And if you do want to do this network related, that's fine. If you want to say, okay, I want to improve the performance of the network, that's totally fine. If you want to do publication, it's okay. If you want to do this production, it's okay. Because anything involving this customer behavior, that's going to be the data there.
So I can talk about those heavy machinery industry, like where Caterpillar operates in, and then competitors so much, so all those goes on and on. I think condition monitoring is a very mature one, and we have sensors in all those machines which are very costly. Cost of downtime is very huge and significant, and condition monitoring has matured in this industry. And in Caterpillar, as I said, we did a brainstorming innovation challenge. What are the use cases that we can do with this kind of IoT data that we have already invented? At least we have in production 2 more use cases, just like prognostics-based logistics. Like logistics, it is enabled by prognosis, and that is also again enabled by IoT data. And another is for at least for Caterpillar, it makes money from its parts attachments. Like it's just like a printer and all. We sell the machine, that is not where we make money. Sell those attachments, they people buy them. Those attachments, again, we are putting some sensors, and we can track what attachment, how much it is working. Like each and we want that data, we can exactly pinpoint where our attachments are being used more like, and we know that some normal lifespan for those attachments are more likely to be needed repair, and those kind of things. Those are in development. So that means it is maturing wherever there is value. And again, we have to justify our return on investment, keeping in mind that this technology is emerging and it is evolving very fast, changing very fast.
Yeah, I would agree probably where the money is, there is most potential already. I mean, oil and gas, aerospace, transport, heavy equipment. This is where the most potential is being reached. I would put health wearables, impact on insurance, both a little bit earlier on in reaching their potential. But there is, movement in all of them. Smart cars, smart buses, there is quite a bit that's already achieved, but there's a lot more to be achieved.
Yes, some questions, research questions I can put to the audience, like they are working, particularly in war, particular policy, like some policy research, how to navigate through this technology is at its infancy, or it is evolving very fast. How a big company should invest or strategize investment, because if you invest to implement or put it in production, it takes a lot, it requires a lot of money. And if it runs the risk of being obsolete very quickly, it is difficult. Right? I can buy one laptop and I have money, and another new version comes, I'll buy it. But if I have to make a decision, okay, I have to buy for the whole enterprise, if it's 5,000 pieces laptop, then if another person comes in 6 months, I'm just locked out. I cannot buy it. So how to navigate through optimally will stay at the cutting edge and still we can do it in the budget. And second one, the data transmission in IoT, big data, from my experience, the costing is coming down, like really exponentially it is coming down, just following Moore's law. But cost of transmission is huge. Until then, I don't see in the next 4, 5, 6, 10 years, it is not, globally it will not be very economically feasible. But during that time, how to still stay afloat? Doing the analytics on the edge or doing the analytics at the back end, we have to do something like to create value. The data will be the same, the sensors will generate the data, the assets will be connected. Those are the basic things, but we have to still show value until that cost of transmission comes down drastically.
So let's thanks for the speaker again.
Thank you.
Thank you.